Welcome back, everybody. Now we take more questions on the sum and product of roots. The next one is, I think the last one we did was number 6. So the next one is number 7. If alpha and beta are the root of the equation 3x squared, that's number 7. If alpha and beta are the roots of the equation 3x squared minus x plus 2 equals 0, find the values of, this is Roman figure 1, alpha beta squared plus alpha squared beta, and that's the same as alpha beta into bracket beta plus alpha, which is alpha plus beta from the equation given is minus b over a, and that's minus 9 over 3. A is 3, b is minus 9, and c is 2. And this simply means 9 over 3, which is 3. While alpha beta, of course, this is alpha plus beta. This is alpha plus beta. Alpha plus beta is minus b over a. So that's minus 9 over 3, and that's 3. And alpha beta is c over a, which is 2 all over 3. That's 2 over 3. Now that simply means alpha beta squared plus alpha squared beta, which is the same as alpha beta into bracket beta plus alpha is equal to alpha beta is 2 over 3, and beta plus alpha is the same as alpha plus beta, which is 3. So that simply means 2 over 3 times 3, that's 2. Now to Roman figure 2, find the value of alpha squared minus alpha beta plus beta squared plus beta squared. That's going to be the same as, this is beta squared plus beta squared. This is the same as alpha squared plus beta squared minus alpha beta. And I know that alpha squared plus beta squared is the same as alpha plus beta all squared minus 2 alpha beta, and then minus this alpha beta. So that simply means alpha plus beta all squared minus 3 alpha beta, which is the same as alpha plus beta is 3, that's 3 squared minus 3 times alpha beta, which is 2 over 3, and that's the same as 9 minus 2, which is 7. And now we go straight to the next, which is number 8. If alpha and beta are the roots of the equation 2x into bracket x minus k equals k squared, where k is a constant, find the equation whose roots are alpha squared. Find the equation whose roots are alpha squared and beta squared. First of all, I can expand the bracket, open the bracket. That will be 2x squared minus 2kx equals k squared, and that simply means 2x squared minus 2kx minus k squared equals 0, which is the same as, okay, that simply means a is 2, b is minus 2k, and c is minus k squared. So alpha plus beta is minus b over a, that's minus into bracket minus 2k over a, which is 2. The coefficient of x is b, and it's minus 2k here, and the constant is c, which is minus k squared, while the coefficient of x squared is a. So alpha plus beta is minus into minus 2k over 2, which is the same as 2k over 2, and that's of course k, that's the same as k. Alpha beta is c over a, which is minus k squared over 2. Alpha beta is minus k squared over 2. Now the sum of the new equations, the sum of the roots, sum of the new roots will be alpha squared plus beta squared, which is equal to alpha plus beta all squared minus 2 alpha beta, and that's the same as alpha plus beta is k, That simply means k squared minus 2 times alpha beta, which is minus k squared over 2. That's minus 2 into bracket minus k squared over 2. And that's the same as k squared minus 2 here 1, 2 here 1. And that's going to be minus 1 times minus k squared, which is plus k squared. So that means the sum of the new roots is 2k squared. Now, product of new roots is alpha squared times beta squared. Or I can simply write that as, let me just write alpha squared times beta squared, which is the same as alpha beta all squared. Of course, I can write alpha squared beta squared as alpha, as the square of alpha beta. Now, that simply means alpha beta is, what's alpha beta? Alpha beta is minus k squared over 2. So that simply means minus k squared. That simply means the square of minus k squared over 2, which is the same as k raised to power 4 over 4. That's the product of the new roots. Therefore, the equation whose roots are alpha squared and beta squared will now be x squared minus sum of roots, which is 2k squared times x minus 2k squared times x plus product of roots, which is k raised to power 4 over 4 equals 0. And we can, okay, and this is the same as x squared minus 2k squared x plus k raised to power 4 over 4 equals 0. Now I can multiply through by 4 to clear the fractions, and I'm going to have 4x squared minus 8k squared x plus k raised to power 4 equals 0. Now this is the equation whose roots are alpha squared and beta squared. Now we go straight to the next. That's number 9. Find the possible values of k, of the constant k, for which the equation x squared, that's number 9, minus 4x plus 1 equals k into bracket x minus 4. The equation is for which the equation x squared minus 4x plus 1 equals k into bracket x minus 4 has equal roots. X squared minus 4x plus 1 equals k into bracket x minus 4. That's a given equation. We want to find the values of k for which it has equal roots. Now I can open the brackets on the right hand side, and I'm going to have 4x squared minus 4x plus 1 equals kx minus 4k. And that's the same as, that simply means x squared minus 4x plus 1 minus kx. I think I can write that here. Plus 1 minus kx plus 4k equals 0. Now I've moved everything on the right hand side to the left hand side, and this simply means x squared minus 4x plus kx plus, no, that's not plus kx. I'm just rearranging. This is the same as x squared minus 4x minus kx minus kx plus 1 plus 4k equals 0, which is the same as x squared minus, open bracket, 4 plus k. This is just factoring minus 1 out of minus 4, factoring minus x out of minus 4x and minus kx. So that's going to be minus into bracket 4. It's actually supposed to look like this in case you are a bit confused. Minus x into bracket 4 plus k plus 1 plus 4k equals 0. But you usually write coefficient before the variable. So I'm supposed to write this as x squared minus, open bracket 4 plus k times x plus 1 plus 4k equals 0. Now this simply means alpha, okay, they said find the possible values of k for which the given equation has equal roots. If the given equation has equal roots, that simply means b squared equals 4ac. Or you can say b squared minus 4ac equals 0. Now what is b? B is the coefficient of x, which is minus into bracket 4 plus k. So minus into bracket 4 plus k into bracket 4 plus k all squared. The square of that will be equal to 4ac, which is 4 times a is 1, 4 times 1 times, and c is 1 plus 4k. That's a constant, times 1 plus 4k. Let me make sure that space contains it. 4 times 1 times 4 times 1 times 1 plus 4k. And that simply means if we square the left hand side, that's going to be 4 plus k squared equals 4 times 1 is 4 times, let me write it this way, 4 plus the square of 4 plus k, this is the same as the square of 4 plus k, equals 4 into bracket 1 plus 4k. 4 times 1 plus 4k, 1 plus 4k, 4 times 1 plus 4k, and that means this will be 16 plus 8k, 16 plus 8k plus 4k plus k squared rather equals 4 plus 16k, and that's the same as 16 plus 8k plus k squared minus 4 minus 16k. That is moving everything on the right hand side to the left hand side, and this is the same as, I can rearrange this as k squared, 8k minus 16k is minus 8k, and 16 minus 4 is 12 plus 12 equals 0. Oh, here I should even put equals 0 here. When I moved the whole of this left hand side, this right hand side to the left hand side, I should have equals 0. And now I can rearrange as k squared, 8k minus 16k is minus 8k, and 16 minus 4 is 12 equals 0. Equals 0. Now, can we solve this by factorization? I think we can. That's going to be k squared minus 2k minus 6k plus 12 equals 0, which is the same as k into bracket k minus 2 minus 6 into bracket k minus 2 equals 0, which simply means k minus 6 times k minus 2 equals 0, and that simply means k equals 6 or k equals 2. So the possible values of k are 6 and 2. Very, very simply. Now, those are the values of k for which the equation has equal roots. Now to number 10 very quickly. If alpha and beta are the roots of the equation, 2x squared minus 5x minus 1 equals 0. Find Roman figure 1. Find the values of alpha cubed plus beta cubed. Alpha cubed plus beta cubed is the same as alpha plus beta. Before I find alpha cubed plus beta cubed, let me find alpha plus beta, because I'll need alpha plus beta and alpha beta in alpha cubed plus beta cubed. Alpha plus beta is minus b over a, and that's minus 5 over 2, which is 5 over 2. And alpha beta is c over a, which is minus 1 over 2. Now, alpha cubed plus beta cubed is the same as alpha plus beta times alpha squared minus alpha beta plus beta squared. I need to make sure that's on a single line. Alpha cubed plus beta cubed is the same as alpha plus beta times alpha squared minus alpha beta plus beta squared. And that's the same as alpha plus beta into bracket. I know that alpha squared plus beta squared is the same as, or maybe I should write it twice. This is the same as alpha squared plus beta squared minus alpha beta. That's just a rearrangement of this. Now we can move further. That's going to be alpha plus beta times alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta. So that means the whole of this is going to be alpha plus beta all squared minus 2 alpha beta minus alpha beta. The minus 2 alpha beta is for, I know that alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta, and there's another minus alpha beta. There's another minus alpha beta here, so that will make it minus 3 alpha beta. That will make it minus 3 alpha beta. I need to make that small enough for the space to contain it. Alpha plus beta all squared minus 3 alpha beta. Now we can simplify. We can simplify further. Alpha plus beta is 5 over 2. That simply means 5 over 2 into bracket the square of 5 over 2 minus 3 times alpha beta, which is minus 1 over 2. Minus 1 over 2, and that's equal to 5 over 2 into bracket. This will be 25 over 4 plus 3 over 2. And that's the same as 5 over 2 into bracket. What's 25 over 4 plus 3 over 2? Let's do that here. The LCM is 4. That's 25 plus 6. 25 plus 6 over 4, which is 31 over 4. That's 31 over 4. And that simply means 155 over 8. That's alpha cubed plus beta cubed. And we go straight to the next, which is, I think, Roman figure. Okay, they actually ask us to find the values of alpha cubed plus beta cubed and 1 over alpha cubed plus 1 over beta cubed. And this is going to be equal to, the LCM is alpha cubed beta cubed, and this will be beta cubed plus alpha cubed. That's correct, and that's the same as beta cubed plus alpha cubed is the same as alpha cubed plus beta cubed over alpha cubed beta cubed is the same as the cube of alpha beta. And this simply means we already know alpha cubed plus beta cubed. We already found that that's 155 over 8 divided by alpha beta is minus 1 over 2. So the cube of alpha beta will now become the cube of minus 1 over the cube of minus 1 over 2. And that simply means 155 over 8 divided by minus 1 over 8. And that's the same as minus 155. Of course, that will be 155 over 8 times 8 over minus 1, and that will be minus 155. Now we go to Roman figure 2. Find the equation whose roots are alpha cubed and beta cubed. Sum of roots will be alpha cubed. Sum of the new roots will be alpha cubed plus beta cubed, which we already found to be 155 over 8. And product of new roots will be alpha cubed beta cubed, which is the same as the cube of alpha beta, and that's the same as the cube of minus 1 over 2, which simply means minus 1 all over 8. Now the equation whose roots are alpha cubed and beta cubed will now be x squared minus sum of roots, which is 155 over 8 times x plus product of the new roots, which is minus 1 over 8 equals 0. And that simply means I can write that as x squared minus 155 over 8 minus 155 over 8x plus let me put this in brackets, and that will be minus 1 over 8 equals 0. Now to clear the fractions, I'm going to multiply through by 8, and I'm going to have 8x squared minus 155x minus 1 equals 0. That's the equation whose roots are alpha cubed and beta cubed. Now I go straight to number 11. If alpha and beta are the roots of the quadratic equation, ax squared plus bx plus c equals 0. Ax squared plus bx plus c, that should be equal to 0. Let me put that. Ax squared plus bx plus c equals 0. Yeah, that's it. Plus bx plus c equals 0. And now show that, okay, let me take that again. If alpha and beta are the roots of the quadratic equation ax squared plus bx plus c equals 0, show that the equation whose roots are, show that, yeah, okay, I think it's better now. Now show that alpha plus beta is minus b over a and alpha beta is c over a. The equation is ax squared plus bx plus c equals 0. That's actually the general form of a quadratic equation. How do we show that alpha plus beta is minus b over a? Now, if alpha, first of all, if alpha plus beta is minus b over a, that simply means x equals alpha, or x equals, if alpha and beta are the roots rather, that simply means x equals alpha or x equals beta. Now, okay, no, don't let me even go that route. The equation is ax squared plus bx plus c, and I know that a quadratic equation can also be written in terms of its roots in the form x squared minus sum of roots, which will be alpha plus beta here, because the roots are alpha and beta, times x plus product of roots, which is alpha beta, equals 0. This is also the general form of a quadratic equation in terms of its roots. So that simply means ax squared plus bx plus c is similar to x squared, or is equivalent to x squared minus alpha plus beta x plus alpha beta. Now, if I okay, I can write the left hand side as, okay, what do I now do? What do I do here? That's equivalent to, but before I do that, before I do the comparison, I think I should make sure that the coefficient of x squared in ax squared plus bx plus c is also 1, as in this one, as in x squared minus into bracket alpha plus beta x plus alpha beta equals 0. So in the given general form of a quadratic equation, ax squared plus bx plus c equals 0. If I divide through by a, dividing through by a, 0 divided by a is 0, so I can just, I don't need to write that. If I divide through by a, x squared plus b over ax plus c over a will be equal to 0. Now I can compare these two equations, this one and this one. So that simply means x squared plus b over ax plus c over a is equivalent to x squared minus open bracket alpha plus beta times x plus alpha beta. They are both the general forms of a quadratic equation. So now comparing the coefficients of x on both sides, b over a on the left hand side is going to be the same as minus into bracket alpha plus beta, and now that simply means alpha plus beta itself will be equal to minus b over a. Now comparing the constant on the left hand side is c over a, and the constant on the right hand side is alpha beta. Comparing the constants, c over a equals alpha beta, which simply means alpha beta, of course, which of course means alpha beta equals C over A. And that's what we were asked to show. Now to number 12, very, very simply. If alpha and beta are the roots of the quadratic equation 3x squared minus x minus 5 equals 0, find the equation whose roots are 1 over 2 alpha and 1 over 2 beta. The given equation is 3x squared minus x minus 5 equals 0. Now from here, we need to find alpha plus beta first. That's minus into minus 1 over 3 minus b over a. A is 3, b is minus 1, and c is minus 5. And this simply means 1 over 3. Alpha beta is c over a. Alpha beta is c over a, which is minus 5 over 3. Now the equation whose roots are 1 over 2 alpha and 1 over 2 beta. Okay, to find that, I need to find the sum of the new roots first, which is 1 over 2 alpha plus 1 over 2 beta. And that the LCM is 2 alpha beta. 2 alpha beta divided by 2 alpha is beta, times 1 is beta, plus 2 alpha beta divided by 2 beta is alpha, times 1 is alpha. And that simply means beta plus alpha is the same as alpha beta. That's 1 over 3. That's 1 over 3 divided by 2 times alpha beta, which is minus 5 over 3. And that's the same as 1 over 3 divided by minus 10 over 3, which is simply minus 1 over 10. Of course, 1 over 3 divided by minus 10 over 3, in case you are getting confused, is the same as 1 over 3 times 3 over minus 10. 3 cancels 3, and that's 1 over minus 10, which is the same as minus 1 over 10. Now, that's the sum of the new roots. Now, the product of the new roots will be 1 over 2 alpha times 1 over 2 beta, which is equal to 1 over 4 alpha beta. And that is same as 1 divided by 4 into bracket. Alpha beta is minus 5 over 3 times minus 5 over 3. And that's equal to 1 divided by minus 20 over 3, which is simply the same as minus 3 over 20. That's the same as 1 times 3 over minus 20, which is minus 3 over 20. Now, therefore, the equation whose roots are 1 over 2 alpha and 1 over 2 beta is given by x squared minus sum of the new roots, which is minus 1 over 10 times x plus product of the new roots, which is minus 3 over 20 equals 0. And this simply means x squared plus 1 over 10x minus 3 over 20 equals 0. Now to clear the fractions, I'm multiplying through by the LCM of the denominators, and that's 20. So that will be 20x squared plus 2x minus 3 equals 0. That's the equation whose roots are 1 over 2 alpha and 1 over 2 beta. Now I go straight to the next, which is number 13. Find the least value of y equals 3x squared. Find the least value of y equals 3x squared minus 4x plus 6 and the corresponding value of x. Okay, to find the least value of y equals that, let me write that on the single line. 3x squared minus 4x plus 6. That's going to be equal to, I think I can take this one out. That's going to be equal to, first of all, I want to make the coefficient of x squared 1, and I can write this as 3 into bracket x squared minus 4x over 3 and then plus 6, which is equal to, now I can complete the square for this one. That's equal to 3 into bracket x minus x, and then half of the coefficient of x is minus 4 over 3. Half of that means 1 over 2 times minus 4 over 3, which is minus 2 over 3. So that's what I'm going to write here. X minus 2 over 3 all squared minus the square of that half the coefficient of x. This is supposed to be minus 2 over 3. The square of half the coefficient of x, half the coefficient of x is minus 2 over 3. So the square of that will be minus 2 over 3 all squared. I'm writing it this way so we don't get confused. The square of minus 2 over 3. And then I'm going to close the bracket to add 6. I need to write that and make sure that the space contains it. So let's take that again. To complete the square for x squared minus 4x over 3, I'll have 3 times x minus 2 over 3. That the coefficient of x is minus 4 over 3. Half of that is minus 2 over 3. All squared minus the square of this half, the coefficient of x, which will be minus the square of minus 2 over 3. Which is, yeah, and that's what I'm going to write. Plus, I close the bracket and then add 6. That simply means 3 into bracket x minus 2 over 3 all squared minus 4 over 9 plus 6. This is 4 over 9 plus 6. And now I can open the bracket here to have 3 times, that's 3 into bracket x minus 2 over 3 all squared. Now 3 times minus 4 over 9 is going to be minus 4 over 3. Of course, 3 times minus 4 over 9 means 3 here, 1, 3 here, 3. That's minus 3 here, 1, 3 here, 3. That's minus 4 over 3. Plus, don't forget this 6 outside, plus 6. And that is same as 3 into bracket x minus 2 over 3 all squared. What's minus 4 over 3 plus 6? Let's do that here. Minus 4 over 3 plus 6, that's 3. And that's the same as 14 over 3 actually. Yes, that's 14 over 3. That's plus 14 all over 3. Now, so they said we should find the least value of y. Therefore, the least value of y, which is same as y minimum, is 14 over 3. And the value of x, the corresponding value of x is this, is minus b over a. This is b over a, minus 2 over 3 is b over a. So the corresponding value of x will be minus b over a. That's minus into bracket minus 2 over 3. And that's the same as 2 over 3. So, oh no, the corresponding value of x is minus b over 2a. Yeah, I'm correct. I was correct. Minus b over 2a. And this represents minus b over 2a. So the corresponding value of x, I was correct, is minus, this represents b over 2a. And the corresponding value of x is minus b over 2a. So that's minus into bracket minus 2 over 3. I take that again. B over 2a is the same as this. This represents b over 2a. And that's minus 2 over 3. And the corresponding value of x, for which y is minimum, is going to be minimum of when y has a least value is minus b over 2a. So that's going to be minus into bracket minus 2 over 3, which is 2 all over 3. Now we go to the next. Okay, it says hence or otherwise find the constants p, q, and r such that 3x squared, find the constants p, q, and r such that 3x squared minus 4x plus 6 equals p into bracket x plus q all squared plus r. Okay, how do we find the values of the constants p, q, and r? What we just do is, okay, write the left hand side in form of the right hand side. So if I try to complete the square for this, what am I going to get? I already did that. This one, if I complete the square for the left hand side, which is 3x squared minus 4x plus 6, this is what I'm going to get. I'm going to get this 3 into bracket x minus 2 all squared plus 14 over 3. So I can just write that for 3x squared minus 4x plus 6. So 3x squared minus 4x plus 6 is the same as 3 into bracket x minus 2 over 3 all squared plus 14 over 3. And that's equal to p into bracket, that's equal to p into bracket x plus q all squared plus r. Yeah, so now if we compare the left and right hand sides, we'll see that P is equal to 3. Comparing the left and right hand sides, P is equal to 3. P is equal to 3. Q is equal to minus 2 over 3. Of course, look at it. What's it outside here on the left hand side is what is here on the right hand side. What is inside the bracket here on the left hand side is what's inside the bracket here on the right hand side. X minus 2 over 3 is similar to x plus q, so that means q is minus 2 over 3, and the constant on the left hand side is 14 over 3, while the constant on the right hand side is r, so that means r is 14 over 3. P equals 3, q equals minus 2 over 3, and r is 14 all over 3. And that answers that question. Now we go straight to the next, which is number 14. If alpha and beta are the roots of the equation, of the quadratic equation 3x squared, let me write that quickly, minus 4x, 3x squared minus 4x minus 7 equals 0. Find Roman figure 1. Find Roman figure 1. Alpha cubed. Okay, I think I should stop there and then we'll continue from there in the next. Thank you very much, and I'll see you in the next. Bye bye.